Well, hey everybody, Mr. Reeves with you for our third and final review video as we prepare for the upcoming quiz on proportional and non-proportional linear relationships. So we first did a video of Module 4 review, then Module 16, and now we are on Module 17, non-proportional, and more specifically, non-proportional linear relationships. All right, so if we look at the vocabulary here, we have a linear equation, which is an equation of something that when graph makes a line, and we can recognize a linear equation in that it can be written as y equals mx plus b, and we refer to that as the slope intercept form of a linear equation because m is the slope and b is the y intercept, right? Y equals mx plus b. And what is the y-intercept? The y-intercept is the point where the line crosses the y-axis. The y-intercept is the point where the line crosses the y-axis, and it will always be 0b. X is always 0. And the reason why x is always 0 is because it's on the y-axis, and anywhere on the y-axis, the x value is 0. So if we were to take a look right here, they have an example of someone saving money to buy his mother a birthday present. So if you take a look right here, right there is our y-intercept. That is 25. More specifically, it is the point 0, 25. So we would say that b is equal to 25. And you can see right here on the table, there is my y-intercept. You'll notice that x is 0, right? And there is my y-intercept. So there is b. So the pair is 0, 25. b by itself we would say is 25. Now the slope, remember slope, is change in y over change in x, and we can see it on the graph. All right, from there to there it goes up 5, right? And then it goes over 1. Now you take a look at the scale. You can see the scale is going by halves, right? So these scales are very much different. This scale is going by 5. This scale is going by a half. So even though it looks like it goes up less, it's actually going up 5 and over 1, up 5 and over 1, up 5 and over 1. All right? So the change in y over change in x is 5 over 1 or 5, which means, all right, that is our rate of change. That is our slope, and it is $5 per week. That, by the way, is also our unit rate. All right, we talked about that in the previous video when we were working with proportional relationships. All right, the rate of change gave us our unit rate. Our slope gave us our unit rate. Okay, what's different now is our line does not go through 0, 0 because we have a y-intercept. So now if you take a look right here on the table, we can do our change in y. That goes up by 5, that goes up by 5, that goes up by 5, and these are going up by 1, right? So again, our change in y over our change in x is 5. That is our slope. What's different now than before? Remember before we had y divided by x was equal to a constant? Well, if you take a look now, we have 30 divided by 1, we have 35 divided by 2, we have 40 divided by 3, we've got 45 divided by 4. Those are no longer equal, right? They aren't the same. So y divided by x is not a constant. So this is not a proportional relationship. And again, we would know that because our line, when we graph our line, it is linear. That's what makes it a line. but it does not go through 0, 0. So this is a linear, non-proportional relationship. So instead of y equals kx, now it's y equals mx plus b, again, where m is the slope and b is the y-intercept. In this case, our slope was 5, and our y-intercept was 25. That is the equation right there. It starts at 25, and it goes up 5 every week. Okay? All right. Well, let's look at some problems. Okay, one of the things we had to do was graph. Remember, y equals mx plus b, right? Y equals mx plus b. So in this case, m is negative 1/2 and b is negative 2, right? So m is negative 1/2 and b is negative 2. Remember, when you're graphing a line, you start at the y-intercept, correct? You start at the y-intercept at negative 2, and then I go down 1. Now again, look at the scale. The scale here is a half, right? So going down 1 and over 2 is that way. Although, because the scales are the same, I could actually go down 1 and over 2 and I would be on the line, right? Down 1 and over 2, and it would work. But if you really wanted to map the actual slope, you'd go down 2 and over 4 because they're going by halves. Okay, does that make sense? Okay, so let's take a look at some problems here. Complete each table. Explain whether the relationship between x and y is proportional or non-proportional, and whether it is linear. All right, y equals 10x minus 4. So this says take whatever x is, multiply it by 10, and subtract 4. It also tells me that the slope is going to be 10, and the y-intercept is going to be negative 4. All right, so if we take a look here, 10 times 2 is 20. 20 minus 4 would be, let me do this again, 10 times 2 is 20, 20 minus 4 is 16. All right, let me skip over to this one. 10 times 6 is 60, 60 minus 4 is 56. Now what about this one? Well, 0, 2, it looks like it should be 4, right? But we don't know for sure it follows that pattern. So what do you do when they give you the y? Well, they're saying y is 36. So 36 is 10 times something, right? 10 times something minus 4. All right, well, if we add that 4 back on, we'd get 40 is 10 times something. So it actually does turn out to be 4, right? 10 times 4 is 40. 40 minus 4 is 36. All right, so again, right here, there's our y-intercept. How do we know it's the y-intercept? Because x is 0. There's our negative 4 right there. Our slope, if we take a look, all right, our change in y, what happened? That went up by 20, and that one went up by 2. That one went up by 20. That one went up by 2, right? So our change in y over our change in x was 20 over 2, which is 10, right? So our slope is 10. So this is a linear non-proportional relationship. Okay, so linear non-proportional. It's linear because it has a constant rate of change, right? Change in y over change in x is the same number every time, 20 over 2, which is 10 over 1. And it's non-proportional because it does not go through 0, 0. And again, another way to know it's non-proportional, if I take 16 divided by 2, or 36 divided by 4, or 56 divided by 6, they are not the same. Y divided by x is not a constant, so it's non-proportional. All right, what about this one right here? Y equals negative 3 halves x. Well, if you put 0, you get 0, 0. Well, that's a good sign right there because it goes through 0, 0. All right, so I'm not crazy about the fact that they use decimals when their slope is a fraction, but we can do this. All right, so y is equal to negative 3 halves, and then we're going to, actually, let me do this one right here, 2. All right, so I'm going to put in 2 for x. Here we go. All right, so I'm putting in 2 for x. That 2 and that 2 cancel, and what do we get? We get y is equal to negative 3. Negative 3. All right. Now, if you take a look right here, do you see from there to there our change in y was -3 and our change in x was +2? All right, if this is a linear relationship, then this is going to go halfway. This is 0, 0. Sorry, this was y was equal to -3 right here, right? Do you remember we have that y equals kx though, right? We talked about k is the constant of proportionality. So what does that tell us? That k is equal to -3 halves. There it is right there, y divided by x. So whatever this is, all right, the relationship has to be the same. Do you see how that is halfway there? So this is going to be 1, right? And this goes the same amount there, so this is going to be 3. If I do -1.5 over 1, that's going to be the same as -3 over 2. That's going to be the same as -4.5 over 3. They all simplify to that same ratio right there. That is my k. So this is a proportional relationship. It is a proportional relationship, and I don't have to put linear because all proportional relationships are linear, okay? Non-proportional could be linear or could be non-linear. So if it's non-proportional and linear, you have to put linear on it. Proportional, you don't have to, all right, because they will always be linear. And by the way, if I graph this one would go through 0, 0, right? They're both linear. This one would go through 0, 0. This one would go through 0, -4. All right, what about this? Find the slope and the y-intercept for the linear relationship shown in the table. Graph the line. Is it proportional or non-proportional? All right, I'm going to start right here. I know that's not what they asked first, but I'm going to start right there because you look for when x is 0. And when x is 0, y is 4. So the y-intercept b is 4. So I immediately know that this is non-proportional. Okay, I don't have to know anything else other than that it does not go through 0, 0. If that number were 0, it could be proportional, but I'm guaranteed now it's non-proportional. Now, I'm not guaranteed it's linear. Now I need to look at my change in y over my change in x, all right? Because remember, my change in y over my change in x, that gives me my slope, right? If that's a constant rate of change, then it's going to be linear. All right, so what happened from there to there? It went up 6, right? From there to there, it goes up 6. From there to there, that one only went up 2, right? Up 6, up, actually, wait a second. My bad. 2 to 4 is not up 6. -2 to 4 would be up 6. So from negative 4 to 2, that one went up 6. This one only went up 2, and that one went up 2. All right, from -4 to -1, that one went up 3. From -1 to 0, that one went up 1, and that one went up 1. So if we compare those, what do we have? We have 6 over 3, we have 2 over 1, and we have 2 over 1. All of those simplify to 2 over 1. All right, so it is not only non-proportional, but it is also linear, and that constant rate of change is 2 over 1 or 2. All right, so then if I went to graph it, there is my y-intercept. My constant rate of change is up 2 over 1, or instead of going up and right, I could go down 2 and back 1, down 2 and back 1, down 2 and back 1. So these are all points that are on the line. Now you notice I got those points by using the slope and the y-intercept. I did not use the table except for that y-intercept, right? But if we confirm -4, -4, there it is, right? I didn't get that point from the table. I got it from using the point, using the slope. All right, -1, -1, 2 is right there. -1, 2. 0, 4 was there, and 1, 6 right there. So by using the y-intercept and the slope, I was able to confirm that those points are correct. Okay? All right, number 4, I think this is the last one we're going to do. Isn't this exciting? Tom's taxi charges a fixed rate of $4 per ride plus 50 cents per mile. Carla's cabs does not charge a fixed rate but charges $1 per mile. Write an equation that represents the cost of Tom's taxis. All right, so we're going to do this first. We need to know what our X and our Y are. So X is going to stand for the number of rides, okay? And Y is going to stand for, X is not going to stand for the number of rides. X is going to stand for the number of miles, and Y is going to stand for the total cost, okay? So right here you can see miles on the X-axis, cost on the Y-axis. I just confirmed what they gave us there. All right, Tom's Taxis charges a fixed rate of $4 per ride. So 0 miles, you are already paying $4. Just to get in the taxi, you now owe $4. So that right there is the Y-intercept. And 50 cents per mile, that is the constant rate of change, right? That's the constant rate. Well, what does the constant rate give us? That's the slope, all right? So the slope is 0.50, and the y-intercept is 4, so his equation would be y equals 0.50x plus 4. Or if you preferred the fraction, 50 cents is half of $1, right? Y equals 1/2 x plus 4. That will actually make it easier for us if we go to graph, right? Because it's going to go up 1 and over 2, right? By the way, I'm confirming the scales here are the same. It's going by 1, so up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to go ahead and connect those with a solid line because you can go part of a mile, right? There we go. All right, so that's the equation and the graph for Tom's taxi. All right, I'm going to switch over to a different color for Carla's cabs. Carla's cabs does not charge a fixed rate, which means that B is equal to what? If she doesn't charge a fixed rate, B is equal to 0. All right, B is equal to 0, but she charges $1 per mile. All right, so that means that our y-intercept, our slope is 1. That is our constant rate of change there. So her equation is going to be y is equal to 1x, or just y is equal to x, right? So from 0, 0, up 1 over 1, up 1 over 1, and so on. All right? You can see that it starts off lower because it starts off at 0, but the line is steeper, right? Because Carla's charging $1 a mile and Tom is only charging 50 cents a mile. Okay. All right. Now, real quick, just they didn't ask us, but what does that mean about Tom? That means that Tom is linear, non-proportional. I'm going to put NP for non-proportional, and Carla's cabs is proportional. Okay, Carla goes through, actually let me do that in red. Carla goes through 0, 0. All right, and is linear, and Tom's does not go through 0, 0, but it is linear. All right, Steve calculated that for the distance he needs to travel, Tom's taxi will charge the same as Carla's cabs. Graph both equations. How far is Steve going to travel and how much will he pay? All right, well, if it's the same for both, it has to be where they intersect. And it sure looks like they intersect at 8, 8. All right, well, let's check it, right? Y equals 0.50 times 8 plus 4. Well, what's half of 8? Half of 8 is 4. 4 plus 4 is 8. So we get y equals 8. It works for that one. And, of course, Carla's equation, y equals x. All right, so y equals 8. It works for that one. So how far is he going? He is going 8 miles. And how much will it cost? $8. All right, so whether or not he takes Tom or Carla's cabs, he's going to get the same result. Now, if he had gone less than 8 miles, you can see that the blue line, which is Tom, is higher. So less than 8 miles, Tom would be paying, he'd be paying more for Tom. After 8 miles, see how the red line is higher? After 8 miles, he would be paying more for Carla. In fact, he will be paying twice as much from there on out, all right, per mile. Okay, so this one's only 50 cents a mile. So depending on how far he wants to go, helps to decide which of those he should choose. All right, so that is our review of Linear Non-Proportional Relationships, Module 17. I hope these 3 videos that I made helped remind you of what we have learned, and hopefully now you're ready, if you haven't already done so, to go through and do the practice problems in HMH. All right, have a great day.